Introduction to Pythagoras' theorem. In a right angle triangle, the side opposite the right angle is always called the hypotenuse. The hypotenuse will always be the longest side in any right angle triangle. So let's have a look at Pythagoras' theorem. Pythagoras' theorem states that in any right angle triangle, the square of the hypotenuse is equal to the sum of the squares on the other two sides. Let's see that in a diagram. So here we have a right angle triangle. We have the hypotenuse, which is here. It's opposite the right angle. And if we draw a square on this side, so whatever that length is, so is that length. The area of this square is equal to the sum of the area of A and the area of B. Let's have a look at a triangle with some values. It'll be easier to see. So in this diagram, we have a right angle triangle with sides of 4, 3 and 5, and we have the right angle here, so this is the hypotenuse, which is length 5. And remember, Pythagoras' theorem states that in any right angle triangle, the square of the hypotenuse is equal to the sum of the squares on the other two sides. So sum means you add these two together. So let's have a look. So the square of the hypotenuse, so 5 times 5, which is 25. So that's the square of the hypotenuse, 5 times 5, is equal to 4 times 4, so the square on one of the other sides, which equals 16, plus the square of 3. We've got 3 times 3, so that is 9. So let's just check Pythagoras' theorem. So the square on the hypotenuse is equal to the sum of the squares on the other two sides. So 25 is equal to 16 plus 9. Pythagoras' theorem is normally written as c squared equals a squared plus b squared. So the square of the hypotenuse is equal to the sum of the squares on the other two sides. Therefore, c must always be the hypotenuse, which is here. When it comes to A and B, it doesn't matter which of these two sides is labelled A and which is labelled B. Let's have a look at this example. We're asked to prove that the triangle is in fact a right angle triangle. So let's remember that if it is a right angle triangle, the square of the hypotenuse will be equal to this square plus this square. So let's put some squares in the diagram. So a square on all three sides. This was C because it's the hypotenuse, the longest side, which was 13 centimeters. Then we have A, which is one of the other sides, which is 12 centimeters. And then the other small side is B, and that was 5 centimeters. Alternatively, this side could have been B, and this side could have been A. It doesn't matter which one is which. So Pythagoras' theorem is c squared equals a squared plus b squared. So this square is 13 times 13, which is 169. A squared, 5 times 5 is 25. And this square is 12 times 12, which is 144. So 169 equals 25 plus 144, which is in fact 169. Therefore, Pythagoras' theorem has been proved, and this is definitely a right angle triangle. Every time you use Pythagoras' theorem, it's not necessary to draw squares on these three sides. All you need to remember is that you're squaring each of the sides. So you're squaring the 13, you're squaring the 5, and you're squaring the 12. So labelling the sides, you've got C, this could be A or B, and then the other side is B. Then C squared is 13 squared, A squared is 12 squared, and B squared is 5 squared. So 13 squared was 169, 12 squared is 144, and 5 squared is 25. Therefore, 169 equals 144 plus 25. Therefore, Pythagoras' theorem has been proved. And that's all you need to do. Now it's your turn to answer some questions. Work out whether these three triangles are right angle triangles. If they satisfy Pythagoras' theorem, they are. If they don't, they're not. Pause the video. How did you get on? Here are the answers. If you answered any incorrectly, have a look back through the video and then have another go.